All right, so now we're back here for part 2. Let's do the second example. Now, in this case, they give us all 3 side lengths. So this is a side, side, side situation. And we have choices. We could actually find any of the 3 angles right now. But I am going to find the biggest angle. And the biggest angle is always opposite the biggest side. So that would be alpha. The reason I'm going to find alpha first is that unlike the law of sines, where there's an ambiguous case where you could have 2 possible solutions, there is no ambiguous case in the law of sines. Just to show you, if I took the cosine of an obtuse angle, 120, I get negative 0.5. Whoops, negative 0.5. If I take the inverse cosine of that answer, I get 120. So it actually tells me 120, where remember that the sine of 120, I get a decimal, and the inverse sine of that answer is not 120, it's the supplement, which is 60. So that's where that ambiguous case comes in. But with cosine, it's okay. We don't have to worry about it. So I'm going to find alpha. So that means I'm going to do a squared. So the a value, here's a, here's b, here's c. 8 squared, that's my a, equals b squared plus c squared minus 2 times those sides b and c, 5 and 4, times the cosine of alpha. Now that's the piece that I'm missing. That's my variable there. Let's evaluate this. This is 25 plus 16. Now I can do minus 2 times 5 times 4. That's minus 40 times the cosine of alpha. We can add 25 and 16. Oh, this is 64, by the way. That would be 41 minus 40 times the cosine of alpha. Now you're going to be tempted to say that's 1 cosine alpha. You cannot do that because this 41 is a constant and this is multiplying the variable. So these are not like terms. I cannot combine these, so what I'm going to do though is move 41 to the other side. That's an equation. And we get 23 equals negative 40 times the cosine of alpha. At this point, now we'll divide by that coefficient, negative 40. And we're going to get a decimal here is equal to the cosine of alpha. Well, to undo the cosine, to break that apart, we have to take the inverse sine. So 23 divided by negative 40, so negative 0.575. So negative 0.575 is equal to cosine alpha. I'm going to take the inverse cosine now of that answer, and we get 125.1. 125.1. Okay, so we then took the inverse cosine of negative 0.575, and what we get is 125.1 degrees. That is alpha. So that is the first piece of this. Notice that this was an obtuse angle. So it's nice that we found that because that means that beta and gamma have to be acute. They have to be less than 90, which means there's no ambiguous case to worry about. Now we need to find beta and gamma. If we find 1, then we can add these up to get 180 and we can get the other one. So it's up to you. You could do 4 or 5. You can use either one. Let's go for beta next. Beta is opposite the 5. Now we could do the law of cosines again, where this time it would be 5 squared, and then this would be 8 squared and 4 squared. We could go through and do that, or we could do the law of sines. I'm going to use the law of sines in this case. So I'm going to come down here. So I want beta, sine of beta, divided by 5, that opposite length. Now I can't use the 4 because we don't know this angle yet. Let's use the 125.1 degrees and the opposite length, 8. So this equals the sine of 125.1 degrees divided by 8. Now when I cross multiply, I'm going to do 5 times the sine of 125.1 degrees. I'm going to do 8 times this, but then I'm going to divide by 8. So let me go ahead and do that and set that up. So that would be the sine of beta. So let's calculate that. 5 times the sine, 125.1, divided by 8. We're going to get a decimal. Now, 0.511, that is the sine of beta. So to get beta, we have to take the inverse sine of that. Now again, when I write it down, I've rounded it, but when I do the calculation, the inverse sine, I'm going to use the whole answer. And we get 8 degrees. And I know sometimes I go to the hundreds place, sometimes I go to the tenths. The tenths is okay. So beta is 30.8 degrees. Now in the picture, so now we know beta is 30.8 degrees. The last thing we need is angle gamma. Well, let's take 30.8 plus 125.1, and we'll subtract that, from 180. So minus 155.9, and we get 24.1 degrees. And those are the 3 answers. We have solved the triangle. In terms of checking it, it's not like Pythagorean theorem where it's pretty easy to check this, but what we can do is we can look at the angle measures. Remember, the biggest angle needs to be opposite the biggest side. It is. The middle angle, 30.8 degrees, has to be opposite the middle side. It is. And the smallest angle has to be opposite the smallest side. It is. So that tells me that I'm probably on the right track here, that I've probably done this right, and I have. That is the end of part 2.